Hey, 7th graders, we have our test today, so I'm going to treat this very much like I did the review in that I'm going to do problems like these are problems like 1 and 2 for every type of problem just about on your test. And then while that's fresh in your mind, I want you to pause the video and do those problems on your test, and then come back to the video, watch another problem, do that problem on your test, and so on. I think that worked pretty well for you guys yesterday. Let's do that again today. So the first two questions are going to ask you if something's a function or not. For the graphed ones, you need to use the vertical line test, right? Draw a straight line up and down, and if it touches the graph in more than one spot, like this one touches in 3 spots, it's not a function, okay? Whereas this one, no matter where I draw a vertical line, it never touches the line more than once. It's okay that it's squiggly, and so it is, yes, a function, okay? On your test, they're going to just have a bunch of dots, so connect the dots. Like, for instance, if that one would be a function, right? Whereas, like, this one would not be, because notice if I draw a vertical line, I'm touching a couple of the dots, right? So think about that. Then if you have just a set of ordered pairs like this, you can tell if it's a function if all of the x's are matched up with with only one y. Notice all our x's are different and they're all matched up with a unique y. So yes, that is a function. Okay, so that's how you do the first couple. Pause the video, do those on your test, and then join me again. Okay, for numbers 3 and 4, you're going to write an equation that describes the sequence and then find a certain numbered term. We'll just do the 20th as an example, okay? So when we set up this equation, we're going to put t on the bottom of our xy table and n up here. All right, this is number 1, 2, 3, and 4, right? And then 20, 28, 36, 44. Okay, so if we're going to write an equation, remember our equation always looks like this. T equals something to our n, right? So then we have to ask ourselves, what are we doing to the n to get the t each time? It's getting bigger, so clearly we must be adding or multiplying, or maybe both, right? I can try multiplying. 1 times 20 gives me 20, but 2 times 20 is 40, not 28. We could try adding, plus 19. No, that doesn't work. So it must be a two-step one. And so what we're going to do is look on the bottom here and ask ourselves, okay, well, how much is it going up by? It's going up by 8 each time. So we must be multiplying times 8, and then we must be adding something else. So 1 times 8 is 8. I'd have to add 12 to be 20. Does that work for the next one? 2 times 8 is 16, plus 12 is 28. Hey, sure enough. 3 times 8 is 24, plus 12 is 36. It's working. There it is. But now we need to find the 20th term. Okay, now I know that's weird because the word term starts with T, but we're going to put that number right here, the 20th number in the list. So you're going to slide that number right here, okay, and then solve, okay? So remember, when you're trying to find a certain term, put that number in for the n, not the t, even though it says the 20th term. That might be tricky. But here, you want to know the 20th number in that list. So 8 times 20 is 160, plus 12 would be 172. So the 20th term would be 172. Why don't you do 3 and 4 while this is fresh in your mind? Okay, for number 5 then, they want you to find 4 solutions for this equation, then write them as ordered pairs. Remember how we did this the other day? We made an XY table with spots for 4 solutions, and you can choose your X's, make it easier on yourself. Why not go easy like that, right? And then just put that in for the X and solve for the Y. Okay, so I'm going to put a 0 in where the X is, plus 3y equals 12, right? And this just cancels out. 2 times 0 is 0. So I have 3y equals 12, and then divide both sides by 3, and I get y equals 4. So when we put a 0 in, we got a 4. This time we're going to put a 1 in instead of a 0. Let's see what happens. 2 times 1 is 2, plus 3y equals 12, minus 2, minus 2. We get 3y equals 10, divided by 3, divided by 3. Y equals 10 over 3. Okay, now we can't really put an answer. Like I suppose you could put that in as a mixed number. That would be fine. So maybe I'll do it that way. I'll erase that 10 there. Let's put it in as a mixed number. That would be 3 and 1/3, right? Okay. Now let's put in a 2. All right, we're going to put a 2 in where the x was. Okay, so we get 2 times 2 is 4, plus 3y equals 12. Okay, we're going to take away 4, take away 4. So we end up with 3y equals 8, divided by 3, divided by 3. So we get y equals 8 over 3, or in other words, 2 and 2/3. Okay. All right, and now let's put in a 3 in that same spot. Okay, 2 times 3 is 6, plus 3y equals 12, minus 6, minus 6. We get 3y equals 6, divided by 3, divided by 3. Y equals 2. And there we go. we go. Now don't forget to do this. Write them as ordered pairs, right? So you'll write them like this, and so on. And 3, 2. And then there's your final answer, okay? So each time, just select any x's you want. Make it easy on yourself. Put those in where the x is, and then solve for y. And those will be your ordered pairs, okay? Do that one while it's fresh in your mind. Number 7, they want you to find the rate of change. Remember, rate of change is this equation, the change in y over the change in x. Careful to put your y on top, okay? So we're going to look at the y's first. What did we change from that one to that one? We went up 3. And then what did we change on the x's? We went up 4. There we go. It's as simple as that. If you can reduce it, do it. That one I can't. There's my rate of change, 3 over 4. Okay, for number 8, they're going to want you to write an equation, okay, to solve. Okay, it doesn't really say that, but they say this phrase. Do you remember this phrase? Whenever we saw that phrase, we thought, oh, this simple equation, this is our direct variation equation. Notice I have that here too. So for number 8, do write an equation that looks like this, okay? And remember, this is your amount for 1, or the amount, the rate of change is your k, okay? So what we're going to do is we're going to find the amount for 1 of something in the problem. We'll see. Notice it's saying 4 gallons of gas for $14. So we need to find the amount for 1 gallon of gas. And that's going to be what our K is, right? Our K is always our constant of change, or our amount for 1. So let's find that. We're going to do $14 divided by 4, okay, to get our K. 4 goes into 14 3 times. We bring down our 0. Goes in 5 times. Bring down a 0, goes in 0 times. So the amount for 1 gallon is 350. So I'm going to put that into my equation. Okay, and now I can solve the question. Find the cost of 20 gallons of gas. Okay, for 20 gallons of gas, I'm going to put that 20 where the x is, and then I could solve and get the answer. So don't forget, you're not only writing an equation for number 8, even though it doesn't say that, this phrase right here means you're writing a direct variation equation. And then you're going to use your equation to solve, just like I did here. Do number 8 while that's fresh in your mind. Number 9, they're going to ask you to use a graph to find a slope of a line. If they don't have dots, I don't remember if they do, draw your own dots, find 2 intersections. Notice they have 2 nice intersections for us already here. And then draw a right triangle between those 2 dots, right? Remember, slope is rise over run. How much up and down it's going, how much left or right it's going, right? Notice ours is 3 tall and 2 wide. And it's positive because it's going up. Watch out on your test. Your line's going down like this, so don't forget to make your slope negative. Okay, ours for this one is positive, but watch out. It's going down from left to right on the test. So do number 9 while that's fresh in your mind. Okay, here's one like number 10. It says find the slope of the line that crosses through these 2 points. So remember, we're going to have to use our slope equation, which is y2 minus y1, x2 minus x1. Remember that? So let's put in our pieces. y2 would be 4 minus 1, right, y1. x2 minus x1. Okay, 4 minus 1 is 3. Now remember, if you end up with 2 negatives in a row, make them pluses. And there we go. There's our slope. Okay, now careful with those adding and subtracting of negative numbers, and reduce it if you can. Okay, that would be how you do number 10. Do that one while it's fresh in your mind as well. Number 11, they're going to ask you to find the rate of change between 2 certain years. So here's one that's very much like your test one. Okay. Remember, this is always your x and this is always your y. Remember, your rate of change is the change in y over the change in x. So let's figure out what it's changing between 1984 to 2007. Let's start with our y. Here's 1984. Here's 2007. How much did it change? It went up. But we got to figure out how much it went up. So let's subtract those two. Okay, 13 minus 8, 9, 10, 11, 12, 13. So it went up 65 for our y. Careful to put your y on top. It's on the bottom of your xy table, but you need to put it on top for the rate of change, right? And in our year, we went from 1984 to 2007. So let's subtract those 2 years to figure out how many years are between those years. 7 minus 4 is 3. We're going to have to borrow all the way across. We get 2, and we get 23. Okay? There's our rate of change. That's not something we can reduce. If you can, do it. But both of those numbers cannot be divided by each other, so there it is. Okay, that's our rate of change. You'll do number 11 the same way. Careful to use the correct years, and careful to put your y's on top. Number 12, they want you to state the slope and y-intercept. So the first thing you're going to need to do is put it into slope-intercept form like this. In other words, get y by itself, right? So that you can see the slope and the y-intercept. So let's do that. Let's get y by itself. So we'll start by taking away 5x from both sides. So this is gone, right? So now we've got this, and then minus 5x we'll put first, okay? And then we still need to make this 2 disappear, this negative 2. So we're going to divide everything on both sides by negative 2. So that's going to cancel out. I can't do negative 5 divided by negative 2, so we're just going to leave it that way. Now notice that's 2 negatives divided by each other, so I'm just going to leave it this, but positive, right? Because a negative divided by a negative makes a positive. So if you can't divide it, just leave it like an improper fraction like that. But this part we can definitely divide by negative 2. That gives us negative 3, right? A positive divided by a negative. And there we go. So there's our equation. Now we can finally answer the question. It asked what was the slope and a y-intercept. Well, the slope is this number before the x always, right? So this is our slope. And this number at the end is always our y-intercept. So there's our 2 answers for that one. Why don't you do number 12 while that's fresh in your mind? Okay, number 13, you're going to see this little phrase again. Remember what this means? Whenever you see that phrase, you should write a constant of variation equation, okay? So we're going to write an equation like this, even though it doesn't say that. And actually, it might say that on your test too. It does on this one. It says the number of centimeters y in a measure varies directly as the number of inches x. So centimeters y, inches x. Don't forget that, okay? Write a direct variation equation, one of these guys, that could be used to convert inches to centimeters if 5 inches is 12.7 centimeters, okay? Now remember, we always want to put our y on top and our x on the bottom. So that's why I jotted this down before. We should put our centimeters on top, right, 12.7, and our inches on the bottom. Now we should reduce this down. We need to get a decimal so we can put that where the k is, right, the amount for 1 inch. Okay, so let's divide. 12.7 divided by 5, the decimal comes up. 2 times 5 is 10. Leaves us with 2. Here comes our 7. 5 goes into 27 5 times. Bring down an extra 0, and there we go. So I'm going to put that in where the x, or where the k is, excuse me. There we go. I've got our new equation. And now we can use that to write a direct variation equation that could be used to convert inches to centimeters. I don't know if we have to use that for anything, but if they do, you could use that to solve how many centimeters is any number of inches. So that might be all you have to do on number 13. Why don't you do number 13 while that's fresh in your mind? Number 15, then, they just want you to write an equation in slope-intercept form, right? That's this, the one we've been using so much this chapter, right? And it tells you the slope and the y-intercept. That's really easy. So if they tell you the slope is 2, put that before the x. And if they tell you the y-intercept is that, put it at the end, right? So that's a really simple one. Do that while it's fresh in your mind. Okay, number 16. This type of problem didn't show up on the review, so I'm glad they're testing us on it now. Okay, so I want you to watch this one especially closely. They want us to write something in slope-intercept form, so we still need to finish looking like this, right? But notice they only give us 2 points. So we're going to have to write it in point-slope form first, and then change it into this. Remember doing a worksheet and an assignment on this? Okay, so let's practice that. Remember, point-slope form looks like this. Does this ring a bell? Okay, so we're going to put it in that form first. So y minus y1 equals mx minus x1. So we need to get our slope first of all, okay? So let's get our slope. We know how to get slope, y2 minus y1 over x2 minus x1, right? So let's get our slope. y2 is 4, y1 is 0, x2 is 2, x1 is 0. So I get 4 over 2, or in other words, 2 over 1. So our slope is 2. So I'm going to put that in where the m is. I'll start rewriting it right here, okay? All right, then let's just pick one of our pairs. Why not this second one? Okay, then we don't have to work with some funky zeros. So y minus 4, I'm just putting the y from that one, and then x minus 2. Okay, so here's our point slope form equation. We still need to change it into this. So I've erased everything to help us have some more room for this. We're going to change this into that, okay? So we need to get y by itself. So the first thing we want to do is do the math on this side, okay? We're going to take 2 times both of these things. So 2 times x and 2 times negative 2 is negative 4. So here's what we've got. So one more step then, right? I still need to get y by itself, so I'm going to add 4 to both sides. That cancels out, so I get y equals 2x, and guess what? This cancels out too. So there's my equation in point-slope form, okay? So don't forget, write it in slope-intercept form, I should say. Don't forget to write it in point-slope form first. Here it is again. It might be helpful to write this down because you're going to need that for number 16, okay? Do it in that form first and then switch it to this form by getting y by itself, okay? Do that one while it's fresh in your mind. Okay, this is actually number 17 right off of your test. They want you to draw a line of fit. So you're going to do that as best you can, draw a line of fit going through that, okay? And then in number 18, after you draw your line of fit, they're going to ask you, okay, well, what would that SAT scores probably be for someone who had a math grade of 55? Now be cautious about that. 55, if I put 50 on this line, because it's going up by tens, right? 55 would be about right here. So go right up and see where 55 crosses this intersection here, and what SAT score would that be, okay? So you're going to use your line to predict. I won't give any more than that, but you're going to use your line to predict what SAT score, that's a fancy name for like a test you take to get into college, someone would have if their average math grade was 55. And careful, 55 is right here. So see where that line intersects the SAT scores, okay? And that'll give you a good estimate. It's just an estimate, so it doesn't have to be an exact answer, but make an estimate of what you think it'll be. So that's 17 and 18. 19 will be one where you solve by graphing, so just one quick one of these. Okay, that top one we can graph right away. We've got our slope. And notice it doesn't have a y-intercept, so we'll just start at 0, right? And then we're going to go down 3 over 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2, and so on, right? So I get my line. Don't forget to make this a straight line on your page. I'll do my best I can right now to do it quickly, okay? Then, for the other one, notice the other one is not in the right form. You're going to have to switch one of them too on yours. It's not in y equals mx plus b form, so you can graph it nicely. So rearrange it. This one we just need to move the 2 to the other side, right? So that the y is by itself. So now we have it. Good. Now we're all set. Now we can graph it, right? Here's our y-intercept. So we're going to start at -2. And this one's slope is down 1, right 2. So down 1, right 2. And notice down 1, right 2. Notice I already see the spot where it crosses. Did you see that? Whenever you have dots that overlap, that's always a good sign that, hey, there's your spot where it's crossing. Don't forget to write your solution like this, right? There's my solution. That's where it crosses. Then for number 20, you're going to solve using substitution. Okay, remember that means you just take what's in that second equation and plug it into the one that's on top. So this one says x equals 4y. So I'm going to replace that x right here with 4y. Here I go. Y equals 4 times 4y. Notice I put 4y there instead of x, plus 45. Okay, now we can solve for y. Okay, so let's do that. Notice we can do a little bit of math right here before we do anything else. So we'll do that. 4 times 4 is 16y, right? Plus 45, okay? And then let's get the y's by itself. So there's a couple ways we can do this. What's probably the easiest way to do it is take away 16y from this side and that side so that the y's are brought back over here. So y, or in other words, 1y minus 16y. Whenever you have a small number minus a bigger one, you add them, subtract them, and use the sign of the bigger number, right? So I get negative 15y equals 45. Divide by negative 15, and I get y equals negative 3. 45 divided by negative 15 is 3. So I've got y. Now remember, we don't have our x yet. Sometimes you don't, even after you've solved one. So we got negative 3 for y. We don't have our x. Okay, we can't go like this. You're never allowed to put a variable. I noticed that on some of our reviews by accident. You can't put a variable in an ordered pair. We got to solve that. So if it tells us that x equals 4y, well then let's just take y times 4, right? If x equals 4 times y, then let's take what y was and put it in for the y there. X equals 4 times negative 3. So in other words, x is negative 12. And there we go. There's our full pair. I'm not sure if you'll have to do that last step on the test or not, but just in case, there you go. All right, guys, that's it. Take your time on that test. Use the video, rewind it if you need to watch a problem again while you're working through one. But most of all, God's blessings. I know this has been a chapter that's been spread way out over distance learning and school, and also just because we had a whole week off and then an Easter break, that just got really spread out. You'll do well with this, especially if you pay attention to the video and use that to help you out. Have a good day, guys.